Hi everyone, welcome back. So GFG problem of the day today is an queen problem. This is a very famous question. For recursion practice, this question is very famous. It is a hard problem, but today we shall discuss the simple solution to this. So what is an queen problem? All those who have played chess must know how the queen moves in chess. So we have an queens puzzle is a problem of placing an queens on a n cross n chessboard. Means we have n queens and n cross n chessboard such that no two queens can attack each other. We have to place n queens on the chessboard so that no two queens can attack each other. So given an integer n, we have to find all distinct solutions to the n queens puzzle. Each solution contains distinct board configuration of the n queen placement, where the solutions are a permutation of 1 to n in increasing order. Here the number in the ith or ith place denotes the ith column queen is placed in the row with that number. For example, 3142 represents this. 2, then 4, then 1, then 3. 3, 1, 4, 2. So how shall we do this? So first of all, we need a chessboard. So we can create a Boolean array, and then we can mark true for the cell where queen is placed and false for the remaining where it is unplaced. So we shall create an n cross n chessboard named Boolean B. Now we have to return the answer of the permutation where the queens are placed in each row. So we have created an array list. For that, array list of array list means 2D array list we have created. Now what we have to do, we have to call a recursive function. Because this question is of recursion and backtracking, we have to find a possible solution to place the n queens. So in the recursion, what we have to pass, we have to pass our board, then we have to pass the number of queens, then the row number, which row we are currently on, and after that our list where we will store the answer. So moving to the our function, we have called the board, the total number of queens, the row, and the list. Now what we see in this question is we have n cross n means n rows and n queens, and we know we cannot place two queens in one row. This we know because if two queens are in one row, they will definitely kill each other. So for each row, we have to try to keep one queen in that row. This is what we have to do for each row, because n queens we have to place in n rows. For each row we have to place one queen, and if total queens we have placed, we have able to place all n queens, we have got our answer. This shall be the base case, otherwise we shall not get the answer. So in each row we can put a loop for the column length for 1 to n and try to keep our queen. If the queen is safe there, we shall place it and move for the next row. If it is not safe, we shall move for the next column. So this is the simple thing that we can think of. We will try doing means from first row, second row, we will place in the first row where it is safe. Then we shall try placing in the second row. Then we shall try placing in the third row. So whenever we are placing, suppose in this row we are placing, the queens will only be in the previous rows, not in the next rows. So we have to check all the previous queens that they are not killing our current position queen. So this we will have to check. So this we have to do using our recursion. So our base case is if we are able to place all the n queens, we have to just use the answer that we have calculated till now, and we have to means we are having our chessboard. We just have to print that means to store the answer in our array list. So for that we have called our function display. This display means to store the answer in our array list. So what we are doing in display, we have created an array list. Now we are putting a loop till our board n cross n, first for rows then for columns, and if it is true means it is visited. So we are adding that column to our list, and afterwards we are adding that permutation to our original answer list, because we want all the permutation, all the distinct permutations. So we got one possible answer, we are adding that to our answer list, means all column positions we are adding this permutation to the final array list. So this was for storing our answer. If we got our answer, that is all that we were able to place all the queens. Now what we have to do, what we thought of, we are in some row and we will put a loop for all the columns and try if we are able to safely place a queen. We will place in that and try placing for the next row. So this is what we are doing. We have put a loop on the columns. Now we will check for current row we are having, column is this column index. If we are able to place on our board in this row and column safely, we are able to place our queen, then we can place it and we will move for the next queen in the next row, tq minus 1 and row plus 1. If for while we will return, we shall have to remove this queen, means we have to backtrack or turn it to the original board if we do not get a possible answer, so we will turn it back to false. Now what is in this save function? How shall we check if our queen in the current cell is safe or not? So what are the directions in which the queen kills? Queen kills vertically, horizontally and diagonally. Horizontally, we know we will not be keeping two queens in the same row, right? We shall only be keeping one queen in one row. So horizontal, we do not need to check. We need to check vertically and diagonally. Now furthermore, we know we only have to check upwards, not downwards, because downwards we will be keeping afterwards. So our already placed queens are only in the upward directions. So upward we have to check for the same column. Suppose here we are. So only the row will be decreasing and columns will be remaining same. So this is our first loop. From row to 0th index, we will be checking if there is any queen placed. Then we have to return false. Now for diagonal, this side, if we are moving this diagonal, so our row will be decreasing and column will be decreasing. So that we will do row and column, both are greater than equal to 0 and both will be decreasing. If any queen is placed already in the diagonal, that means we cannot place, so it is unsafe, so we will return false. Now this diagonal is done. Now next remaining is this diagonal, right side diagonal, right top diagonal. So how we will do that? Rows will be decreasing, column will be increasing in this case. So same thing we have done, row and column, both rows are greater than equal to 0 and column is less than equal to board dot length, because column will be increasing till the board length. Now rows are decreasing and columns are increasing. If any queen is placed in the diagonal, we have to return false because our current queen will not be safe. If all these conditions do not return false, means our position is safe to place our current queen, so we will return true. So this was how we will find whether we can place our queen on the current row and current column. If we are able to place, we shall put the queen and move for the next row, check whether we are able to place in the next row or not. This way our recursion shall do the same job. If we have got a possible solution, means we are able to place n queens, we shall add our answer to our answer list. Otherwise, we shall come out of the loop and return. This was the backtracking step. That means when we come back to the previous step, we remove the queen from that position. So that our further paths can be checked. Means we will try to keep a queen. If we are not able to find our answer, we will remove it and try for the next cell, next column. Same process we will keep on doing. Means for each column we will try to keep and find a possible answer. If we have got a possible answer, we will add it to the answer list. Otherwise, we shall just move backtrack. So this was the recursion plus backtracking solution for the n queen problem. Simple solution. I hope you guys would have got the approach. Thanks for watching the video. Have fun. Bye.